Okay, so now I've placed them. I haven't routed any wires yet, but I've placed them. I'm going to hit F12 to see if it looks, if there's anything obvious that I can see that I can move around. Maybe this diode, if I rotate that, looks a little bit better, possibly. And you can spend a lot of time. That's better. And you can spend, and you should spend a fair amount of time at this point rotating these guys around to try to, and moving them around to try to make everything as clear as possible. Why not put this test point next to this resistor since it belongs next to it? Okay. I don't know if we're going to get a whole lot better than this. All right. Next step is we need to add mounting holes. So up in the upper side, you'll see a mounting hole option. So you can click it and place a mounting hole. That is a ridiculously tiny mounting hole by default. I don't know why they do that. So open up a web browser and type standard mounting hole screw is a number 6 screw. So type a number 6 hole size. And it will tell you that a standard diameter for a number 6 screw should be 0.138. You can right click this, choose properties, and change the hole diameter to 138. Now that just drills the hole, but you want to have a keep out area around it. And the keep out area is important. Imagine the screw going into this hole, and there's a head of the hole. There's the head of the screw that's bigger than the hole. Any traces that get routed too close to the hole will get shorted out by the head and they'll get shorted together. So choose a keep out area that's significantly bigger, let's say 0.25. And now you'll see a shaded area and it will not allow any traces to go there. So now that you've got that nicely set up, we can Control C and Control V it a few times and put them in the corners. And then this jack should probably be moved a little further away from the mounting hole. And now we've got them set up. Okay. At this point, you're going to let the program run its magic. You're going to say route, run auto router, and just sit back and enjoy the show. By default, it's going to set you up with a double-sided board. And that double-sided board will have on one side, on the top side, traces that are mostly horizontal. You see those in red. And there's a drop-down box on the top. You can take a look at the bottom, and those bottom traces will be mostly in the opposite direction. If one's horizontal, one will be mostly vertical. It did not do, there's a lot of long traces here because I did a really poor job putting the components down. You'll do a much better because you'll be copying them from the, you'll be grouping like components together from the schematic. Okay, and then the next step is to pretty this up. So you can see right now that a lot of these traces are way too close together. Before I get into the details, I want to explain what we're actually looking at. The top of the board is the top as you're looking down on it. The bottom is not that board flipped over. The bottom is an X-ray view of that board through the top. So you'll notice from the top to the bottom, all the holes don't change position. They don't move left, right. You're looking at an X-ray view down through the bottom of it. That'll help orient you. Okay, you do not want to have these traces so close together. Small signal line traces that have rapidly changing signals. This is a conductive layer. This is a conductive layer. It's separated by a tiny little bit of insulation. That's what a capacitor is. So there's an invisible capacitor that's hooking this wire up to this wire, and it will link your signal. It can link your signals together. So there's no reason to have these wires so close. So just take your cursor and drag the wire out. You want to do that anytime you see wires unnecessarily close. This is ridiculous up here. So just take that wire and drag it out away from everything. It's getting a little close to this jack, so take that and just drag it out. It just does the right thing. Take this wire and drag it out to separate it. And that gives you much more breathing room as you go. Now you'll notice one thing that's kind of weird. there's a lot of 45-degree angles here. You don't see a whole lot of 90 degrees. If for some reason you get a 90-degree like bend like this, the problem is you could imagine something getting under that trace and lifting it up. So give it back that 45-degree angle. It'll make the traces less likely to lift up. All right, so you can I recommend spending a little bit of time separating all your wires out so you get a little extra room. Like this. Okay. You know, like why did they have this wire so close? There's no reason for that. Sometimes you'll see these little guys that were added. These are called vias. The vias are through holes through the board. They will be filled inside with copper. And so they'll be, at this point, it connects this bottom trace to this top trace. I recommend keeping your vias away from everything too, just like we just dragged it. So you can neaten things up quite a bit. I'm not going to take the time to do it, but you can neaten up here too. Maybe you say that this whole IC is just hopelessly too tight and you want to move it. Watch how we can move things. You can unroute everything if you want to. There's a choice under routing rather, to just unroute all. If you want to unroute all the wires connected to this this dip, you can select the dip with your arrow button, right click it, and choose not disconnect traces. That will keep the traces there, but disconnect it from your device. I have no idea why you'd ever want to do that. Don't ever touch that one, but unroute traces. And now all the traces with that particular component have been unrouted. And now maybe you can rotate that component and put it in a different location. We don't need that little trace either. Put it in a different location. And now maybe it'll route better when you choose the route. So the run auto router, same thing as you did the first time, it'll just route the traces that were currently unrouted. It'll keep everything else you've done the same. So maybe that's a little bit better. And now you can move things around to spread these guys out. I certainly would. You can spend a lot of time funking around with this. And honestly, if you're going to be building, if you're expecting to be building eventually 10,000 of these boards, I would spend a lot of time funking around to make sure that your wires are separate. If I was designing this particular board for industry and I saw all these long wires up on top, I would say that's a sign that I got to get this chip closer to my LCD. And I would be actually really sorely tempted to say, route, unroute all, move this LC down. Let's move this capacitor out of the way, and then move this guy up on top of the LCD. And I don't know, does that look any better? Does that look any better? I think it will. You can highlight multiple things and move them all at the same time. And I have a feeling that this will make what we're doing look a lot nicer. Let's try rerouting it. Yeah, I don't know if that did or not. Anyway, I would try doing that a few times. This still looks pretty horrendous, doesn't it? You can see that it's routing a whole bunch of wires inside this chip. Don't let it do that. Pull it out. And that'll give you a lot of extra room too. Still not super happy about that. I would. This is why it's so important to go from your schematic and not allow the program just to arbitrarily place things. I'm going to do this one more time and see if we can get something that looks a little bit nicer. I'm going to change this around by placing it next to the LCD and see if that gives us anything better. So here's our route. Yeah, that looks a little bit better, I think. Lordy, I chose a bad example to do this for a recorded arrangement. I don't like any of these. One last try, and then I'm going to leave my OCD-ness alone. Okay, actually, that does look better. Now we can move. Now we can see how we can separate these guys.